Thank you very much for having me here. It's a pleasure. It's an honor. Yeah, my last name is unpronounceable. This is my original last name, Chukharev. It's a very typical Russian last name. My wife is originally from Finland, so Hudilainen is a very typical Finnish last name. So when we got married, we decided to hyphenate our last names, so we didn't think about consequences. One is that nobody can pronounce it anymore, so I'm on first name terms with undergraduate students. Actually, I'm mistaken for an undergraduate student. That's the only reason why I dress up, because this way I get mistaken for a graduate student. less offensive. The second issue with my last name is it doesn't fit anywhere. Anyway, I will be talking about how linguistics, computer science, and language pedagogy can be combined, and how I combine them, and what challenges and results I've had so far. I am currently at Iowa State University, and this is our beautiful and picturesque campus, which unfortunately does not beat Notre Dame, but it's still very beautiful. But I'm in the English department, so I work in this building, which is officially the ugliest building on campus. And prior to joining Iowa State in 2012, I spent 6.5 years as a senior software engineer with the Central Bank of Russia, which is like the Federal Reserve in the United States. So here I am with my colleagues on the last day of my work. This is probably more impressive, you know, with all the screens and such. I will be talking about linguistics, computer science, and language pedagogy. And when these three things are put together in one sentence, the obvious question is why? Because they're so different, you know. So how come? So my personal story is that the reason why I decided to go into computer science and software engineering was because I was very much interested in artificial intelligence and building machines that would be able to think. And then, of course, when I started learning how to build machines that are able to think, I became very curious about how people think, because, you know, when we build things, a lot of times we look at how nature has built those things in humans and in animals and such. So wouldn't it be nice to also try to see how humans think? And then when you start looking into how humans think, there are three basic ways of how you can research that. And one way is, you know, opening up the cranium and, you know, sticking needles. It's very into the brain. It's very invasive. Plus, we don't see much. We see electric activity, which maps very poorly and at a very general level to the actual cognitive processes. Then the second approach is obviously the behaviorist approach. We can observe how humans behave, and we can therefore judge how they think, which is very unproductive. It works great with animals, but humans tend to be, you know, less predictable, unfortunately. So, and then there is the third way, which I find the most exciting, is to look at how people talk, because by looking at how people talk, how people write, how people read, how people process language, you can learn a lot about how their brains function. So for me, linguistics and artificial intelligence are so closely related under this umbrella of cognitive science that I can't even think about them being separate. So for me, it's obvious. I mean, there is no other way to study human cognition, but by combining linguistics, cognitive linguistics primarily, and artificial intelligence. And language pedagogy is, well, when you begin combining linguistics with computer science, the obvious thing that comes to mind when you tell somebody about it is computer-assisted language learning. So how can we build systems that can help students learn languages more efficiently. Although a lot of people a lot of my friends who are cognitive linguists or who are computer scientists don't like me because I, go too much into the practical field of helping people learn languages, and this is not what a scientist is supposed to do, but, well, I have a degree in engineering, and I like building things, so why not? It's fun. So that's why. And today I will be talking about three concrete areas of the intersection between these three different things, just as case studies, to help me show how I think computer science, linguistics, and language pedagogy can be or should be combined. So the first thing I'll talk about will be writing in ESL contexts, teaching writing, and then all the research that comes into it. The second context I'll talk about is vocabulary teaching and vocabulary learning. And finally, pronunciation. So I will begin with writing, and that's one of the projects that I currently lead at Iowa State University, and I'm very proud of doing that, but I'm also very proud of having created a 1-minute video that it took me a month, but I'm probably even more proud of this part. So let me go to the website and play the video. Okay.
Originally, CyWrite was conceived as an open source, automated writing evaluation system for students of English as a second language. Over time, however, it evolved into an integrated environment for supporting not only students and teachers, but also researchers of writing.
We develop hybrid natural language processing techniques, rule-based and statistical, to identify mechanical, grammatical, and discursive features of the evolving text, and to provide instant formative feedback to learners.
CyWrite can also track and analyze the process of composition in real time, identifying bursts of writing, pauses and revisions, and adjusting its feedback accordingly.
CyWrite can be used in classes and by individual students outside of class, even after their course is finished. It was developed to work with any learning management system or from a standalone website, so it's very accessible.
So the biggest thing I learned from this month of making this video, it's very important to have a good microphone the first time you record it, because we didn't, and then we had to dub everything, and then it took, quite a bit of time. So now, if Volker Hegelheimer, the first person who was talking in this video, couldn't get his first word originally synced with his picture, so when he was dubbing himself. So now if you sneak up on him and say originally, he will just freak out, because this is the word he said several hundred times when he was trying to make everything work. And Carol Chappelle was just like natural. I mean, she did it the first take, I think, or the second take. Okay, so obviously we made an automated writing evaluation system, which is definitely a crazy thing to make in an English department. But let me tell you a little bit how we came to this and what underlies this. So this does not pertain specifically to ESL writing, just to teaching writing in general. There are these two cool things called automated essay scoring and automated writing evaluation. And automated essay scoring is very much associated with this company, which I think some of you might have heard of, Educational Testing Services, the people who make TOEFL and other high-stakes standardized tests. So in olden times, when there is this essay component in these tests, and in olden times there used to be two raters at ETS that would read each essay, and then if their ratings were supposed to match, and then that's the grade that the student gets, the test taker gets. Even though ETS did a wonderful job at training their raters so that they're very reliable, and I think they spend like 5 minutes or so on each essay, so they're like rating machines, they're very good raters. But they're still expensive. So ETS built this wonderful thing called e-rater, electronic rater, which is actually in a lot of times more reliable than humans that rates those essays. Now they've got a human and a machine, and if their grades, if their ratings match, that's the score that the test taker gets. If they don't match, they get another human. But a lot of times, if they don't match, it's human error, it's not machine's error. So this is a very, very reliable thing. And because it's when it rates essays, it looks at all different measures of text quality. And then ETS started thinking, well, if we can do it for summative assessment, we can also do the same thing for formative assessment. So how about we repackage our e-rater, and they called their repackaged thing Criterion, as a pedagogical tool that that instructors and students in writing classrooms could use. So a student writes a draft of their essay, the student submits this draft to Criterion. Criterion runs this draft through the same engine that e-rater is, through the e-rater engine. But then in addition to giving the holistic score, which we know is quite reliable, also this rating engine could give some formative feedback as to how the student can improve. What a wonderful idea, isn't it? So some of the things that e-rater looks at actually are not very helpful for the student. For example, I think, I'm not quite sure if I'll rank things here accurately, but I think one of the best predictors of writing quality is the number of sentences in the text. If there are more sentences, the student is likely to get a higher grade. But pedagogically, it doesn't make a lot of sense to tell the students just write more sentences. We don't care if the sentences are bad. Actually, a lot of times, pedagogically, it's more appropriate to say write less but better. So this is one of the examples of features from e-rater that could not transfer directly into Criterion. The second best predictor probably is the average sentence length. So the number of words on average in a sentence in students' writing. And of course we cannot provide feedback to students saying, put more words in your sentences. I'll show you an example in a second that will prove that this is, of course you know that this is the case, but I'll further reinforce my point. Anyway, let's take a look at this sentence. It's a genuine sentence taken from one of Iowa State's students' essays. When I look at it, I mean, yeah, there are a lot of words, but language is lacking somewhat, right? So the student really needs to work on cohesion and grammar and vocabulary, and although I think I can guess what the student is trying to say here in this sentence, if you're in the country, you can feel some sad because you're just one in somewhere, no family, no father and probably mother to help you. You're not happy anymore. If you said, I think I can help you, the solution is your neighborhood. So, I mean, I think I'm getting the point, but it's definitely not good writing, and the student could benefit from some formative feedback. Now, let's take a look at what Criterion says about this sentence. It says, extra comma, and I agree. It's absolutely accurate. It only finds one extra comma, but there are a lot of extra commas here. But to begin with, there's no language, there is no grammar, there is no coherence. I mean, extra comma is definitely a very accurate thing that has been detected by Criterion here, but the student would not probably benefit from this kind of feedback, at least at this point in their, learning trajectory. So that's why we decided to build our own automated writing evaluation system, because the existing systems tend to be made by people in natural language processing, whom I respect a lot because I'm one of them, but they're great people, but a lot of times they don't talk to applied linguists and applied linguists would know, and even, I mean, practical teachers would know that at this point probably some kind of different feedback should be given to the student. Another another good example of the benefit of communication between applied linguists and people in natural language processing is that, for example, there are a lot of papers focusing on automatic identification of article errors in ESL student writing. Research in applied linguistics, however, shows that article errors are not treatable. So even if we tell students where the problems are, they will not learn. So maybe why waste those millions of dollars to build a system that will detect article errors with high level of precision when the outcomes of this, development would not be quite practical, because we know that students just don't learn articles as easily as we would have liked them to. So we built CyWrite starting from the linguistics perspective. So we looked at what kinds of things students would benefit from, and we put together a bunch of applied linguists. We taught them how to program, and this is what happened. So our system has this linguistic analysis module that is not entirely statistical in the way natural language processing currently is. So the problem with natural language processing is that it is a black box, like all statistical machine learning. It's a black box. It can give you good outcomes. For example, it could produce a nice parse tree of a sentence, but it will not be able to explain how it arrived at it. And when we provide feedback to students, we want to be able to explain exactly why and how the student made a mistake or made a wrong choice, or a choice that doesn't work as well, and how the student can improve. So we want to make a white box. So we ended up building a hybrid system that does have the statistical natural language processing foundation, but on top of it we've got rule-based natural language processing, which translates much better into feedback to students. So this parse tree is produced by in our system is produced by a statistical machine, but then it's passed onto a system with of hundreds of manually crafted rules that our applied linguists created after they learned how to program in logic. The syntax is actually Prolog, a long-forgotten programming language that we unearthed. It works great in this application, and then feedback can be provided to learners through a special feedback subsystem. So we take feedback very seriously in the system. It's a lot of times the student will be happier with feedback which is less accurate but more actionable than feedback that's very accurate but not actionable, like write more words in the sentences. And then pedagogically relevant feedback is provided to students. So that's basically the idea behind CyWrite. A nice side effect of our work was that we actually outperformed Criterion by ETS on some errors, because on top of the statistical natural language processing that everybody has, we have our handwritten rules. So the problem with the rules is that you have to be a linguist in order to develop them. And people in natural language processing don't come from the linguistics background anymore. They come from the computer science and statistical background, so they can't write rules. And linguists can't write rules because they're not trained to. So we decided to train them and see what happens, and we really liked what happened, and our graduate students were very happy that they could be a part of it, and so. A lot of numbers, but basically the red ones are the better ones, and we do better than Criterion in some of the features that we've analyzed. Sometimes the difference is marginal, but if our system does at least as well as the best out there, the best commercial one out there, I'm still happy. So I'll show you another example of a good collaboration between computational linguists and applied linguists. This is another project that was done at Iowa State University. A computational linguist and an applied linguist worked together to create this research writing tutor. It's a system that is trained on a large corpus of research writing in 30 different disciplines, and 900 articles in these disciplines were annotated manually for rhetorical functions of each sentence. They're called rhetorical moves. So then a student, this system is for graduate students, ESL and native as alike. A graduate student would input their draft of a paper into this system, and the system will automatically identify rhetorical moves in the student's paper and compare these moves to the exemplary paper in the discipline. And then it can provide feedback to the students along the lines of, you focus too much in your introduction section on identifying the niche. In your area, biomedical technology, people tend to talk more in the introduction sections about addressing the gap, but not identifying the niche, not establishing the territory, things like that. I think it's a brilliant, a brilliant system, and it was initiated before I joined Iowa State, and it was, when I saw it, actually, it was one of the reasons why I decided to take this job. If people do cool things like this, I would like to be a part of this department. The only little glitch here in the system is that so it's trained to identify the rhetorical functions of sentences in research articles based on a manually annotated corpus. So the features it looks at are n-grams, so sequences of 1 word, 2 words, and 3 words, and then so lexical signals. So there are certain lexical signals within a sentence that tell the machine that, hey, this sentence is performing this rhetorical function. Now, when students learn how to write, they might not have those lexical signals. That's the problem. So if you train a system like this on a corpus of expert writing, and then you give this system student writing, students might not have the necessary formulaic language. So this is a little bit of a shortcoming in the original design of the system. And I think the reason why this shortcoming appeared, although the system is wonderful, but it's because the computational linguist and the applied linguist were two different people. And when they are two different people, communication between them, is not as good as if one person would have two skills. It's not like the conversation between the two hemispheres of your own brain. As a result, this is something that they both a little bit overlooked because the computational linguist probably didn't know as much about applied linguistics. The applied linguist didn't know as much about computational linguistics. So, as a result, it works. It's the only system in the world that does this, but there is this principal methodological shortcoming that was there in the very beginning. When I saw this, I thought, okay, so let's then create people who have all skills in their brains. So how do we go about that? So computer scientists at Iowa State have not been especially interested in linguistics, and that's understandable because they've got other things to do, which are very cool and very interesting. So I decided to try and teach linguists to become computer scientists to an extent so that they could program. So a student cannot graduate from us anymore with a degree in applied linguistics and technology, with a PhD in applied linguistics and technology, unless they learn how to program. And this student who recently defended You saw her in the video, she had Hello Kitties everywhere. It was actually an insider joke. So she was in the video, she runs this complicated script that does all kinds of different calculations in the background, and she has Hello Kitties everywhere because she's so Hello Kitty. She really does have Hello Kitties everywhere. So now I call her Dr. Kitty after she has graduated. So in her dissertation, she has found a way to address this shortcoming because she was both a computational linguist and an applied linguist in one brain. So she created a system that helps Taiwanese EFL engineering graduate students write abstracts of their papers. And because they don't have the necessary formulate language, if your system is not able to identify rhetorical moves in the abstracts, it just asks the students to identify the moves. That's very simple, but I thought it was brilliant when she came up with this idea, because the student knows what they're trying to say in this sentence. So the student tells the computer, and then the computer comes up with some very concrete suggestions. Oh, you're trying to do this here, you're trying to introduce your study in this sentence of your abstract. How come you're using all the language from the discussions? This is introduction. Here are some of the lexical bundles you might consider using. And by the way, why are you using future tense here? You should be using present tense here. And all these kinds of suggestions that are very, very useful to students. She actually developed her own system and she piloted it with real students in Taiwan, and she had very good results. So everybody improved. So I think this two-in-one approach is kind of more, a lot of times more efficient than having a collaboration within a team. But when it's not realistic, then at least the applied linguist should know something about computational linguistics, and a computational linguist should know something about applied linguistics, so that there could be some kind of a productive collaboration. Okay. So more about writing. When I first started looking at writing and started building this automated writing evaluation system, oh, did I spend all the time with it? Sorry. Shall I carry on? I'll try to speed up. I'm so sorry, I was not got carried away. Okay, I'll move very fast through this. So we try to teach writing as a process. We try to help students learn how to write better. But we judge them by looking at their products. And this is a little bit of a controversy. So we look at their essays, we look at the text that they give us, and we try to infer what cognitive processes occurred in their brains, and we try to fix those cognitive processes. But we don't know how they actually write, because we don't stand behind their shoulders. So I thought, well, let's build a system that stands behind students' shoulders, and I'll just play this very quickly. I feel so sorry.
You're fine.
You're fine.
We're enjoying it, so.
So our system, CyWrite, is actually capable of recording all students, this process of composition. So this is an example of a student starting to compose a timed assignment. So the student has 15 minutes to compose this assignment. So a student begins very well by, and then the student is obviously struggling with some surface correctness issues, and okay, of course he or she tries to get these words right. So anyway, as you watch this playback, you'll see how the student is trying to address too many surface issues too early in their process of composition. And this is something the instructor wouldn't know, because the instructor doesn't sit there and watch how the student writes. Our system is now capable of tracking the process of writing automatically. Plus, because we want to infer cognitive processes, we look at the pauses that the student makes. A lot of times, these pauses will be even not consciously registered by the student. So a student is starting to write a sentence, and then the student pauses. And then, if he pauses, he's probably thinking about something. If we can infer somehow what the student is thinking about, we can provide more targeted feedback. And this is what we are after in this NSF round. We are also building eye tracking into our system. Eye tracking is a way of automatically telling where the person is looking at on the screen. psychologists have been using eye trackers to study writing for ages. Unfortunately, a decent eye tracking system for the research into writing processes would cost the one at Nottingham Trent, actually the only one in the world that does what I needed to do, £40,000. Well, it's a lot of money. You can't equip a whole classroom with these devices. You can't make students buy something that costs £40,000. We built our own system using cheaper equipment and developing our own software, which costs $500. So we are now equipping a whole classroom, with an entire classroom at Iowa State, with these devices, eye tracking devices. So when a student pauses, we see where the student looks at, and that tells us what the student is thinking about, and then we can provide more targeted feedback. So now see, the student is really in trouble, so 5 minutes elapsed out of the 15 minutes, and then okay, I will not, because I'm really out of time, I will not play this whole thing, but then the student will actually delete everything and start over, and the final product that the instructor will see will be just a segment of the first sentence that the student started. So when the instructor tries to grade this, of course the student will probably get an F, but the instructor wouldn't know where the problem was. The instructor wouldn't be able to see all this hard work that was actually put into writing this chunk of a sentence that the instructor sees in the submitted draft. And this is what we are trying to, this happens much more frequently than we can think. This is what we are trying to address in this work with the process of writing. I also wanted to talk about vocabulary and okay. You're too kind, guys. So, I'll try to, okay. This is a project, it's called Linguitorium, that has to do with vocabulary learning. I started it, the reason why it has a fancy website is because I started it before I joined Iowa State, so there is a company in Russia who actually does this, and I work with them a little bit as well. So they do, like, at Iowa State they build prototypes, this is the real thing. Learning vocabulary is very important, especially in foreign language context when the student is not immersed in the target language environment. There are a lot of wonderful techniques such as flashcards and word lists and activities and other things that the teacher can try to do with their students. Now, the students would not necessarily do all these flashcards. I remember myself as a student of English, I never did them, but I told my instructor I did. So I keep wondering if other students might be doing this as well. The reason why students don't learn words is because it's boring. So my idea when I built this system was to try and strike a deal with the students, say, okay, you do your boring thing, you have to do the boring thing I tell you to do, but you do it just for 10 minutes a day. So it's like, you know, a lot of instruction and language instruction as well nowadays revolves around this idea of self-regulated learning and teaching students how to learn better, and that's all great. And I like to compare it with wellness, well-being. You know, you exercise, you go to the gym, you eat healthy food, and then you don't get sick. But sometimes you do get sick, and then you need a pill, and then you don't care if the pill is tasty or not, you just have to take it. So in vocabulary learning is like that untasty pill, but if designed properly, it might still help. So that was my idea. I saw a gap right there, because this is a very boring thing that students have to do. They would benefit a lot if they knew the words when they came to class, so that they could actually use the words in context, in all those great activities. But if they don't learn their words, then the class time is wasted, especially in EFL context when there is no immersion. So the student does work only 10 minutes a day on activities which look like this. This is a semantic sorting activity. It's actually not the most boring one. A lot of different words like customer, drug dealer, and lever, and the student has to sort them into food, person, and device. This is a simple matching activity. The student hears a word or reads a word and finds the correct definition or the correct pronunciation. Translation. The idea is that the instructor would enter a word list into the system, just a list of words that the students should acquire, and then the system would take it from there. It would develop, it would create those 10 minutes worth of activities automatically, drawing on databases from psycholinguistics, it even finds pictures automatically, so from doing a lot of natural language processing stuff under the hood. But the way it works, the way it works from this, from the surface, is just like this. The instructor enters a word list, and then students do 10 minutes a day, and then we have found that they are basically guaranteed to learn these words if they do 10 minutes a day. So, of course, the system is driven by a psycholinguistically justified model of lexical memory, and it does a lot of interesting things under the hood that I can't get into right now. And we did, just like people in pharmaceuticals test their drugs which don't taste well but are supposed to work, we did a double-blinded, placebo-controlled study. So we selected a population of students who are entirely unmotivated to learn English, cadets at Admiral Makarov State Maritime Academy in St. Petersburg. But because it's a semi-military institution, they do what they're told. So they are told to work with our system 10 minutes a day. Now, how do we do placebo control? That's the trick, right? Because how do we separate out the effect of the instructor's enthusiasm about the teaching method and the effectiveness of the teaching method itself? And here is where actually computational methods and software engineering could help applied linguistics, because in applied linguistics, true placebo-controlled experiments are impossible. Most of the time, because the instructor will know which method he or she uses. And controlling for variables is extremely difficult, so a lot of times we do quasi-experiments rather than real experiments. It's very difficult to control for conditions. Here we could control for conditions because every student, every cadet worked with the same software, but there were 112 different words that the students had to learn. Most of them were, as you can see, special terms from marine engineering. Some of these words were randomly excluded from each student's exercises within Linguatorium in a way that nobody knew which words were excluded. So here enter placebo control. So students worked with the same system. They thought they were presented with the same vocabulary. All vocabulary was practiced in class. Nobody knew that 1/3 of the words were randomly excluded from these exercises, and then we just compared the words that were excluded from these exercises and the words that were not excluded. Plus, for every cadet, we had a different set of words that were excluded, so there was no effect. Everything was counterbalanced, so it was an insane statistical power here. And then these are the outcomes. 3 times better when the activities were done, for the words for which the activities were done. And this is placebo controlled, so even if the student didn't believe in this system or this learning method, a lot of them didn't, even if they did what they were told, when they did it for these words, 50% retention. When they didn't, when the words were randomly excluded, 16% retention. So, I mean, this is when drug manufacturers become excited and they start selling the new medication.
How long was long term in that?
This was just within 1 semester.
So when you have separate those short term and long term, so how?
In this particular experiment, no, it was just long term. It was at the end of the semester. So after the activities were done, and then at the end of the semester, students were evaluated. in a separate study we did, in another study we did long-term and short-term, and long-term retention was of course inferior to short-term retention. It was expected, but there was a good effect on long-term retention and short-term retention. And pronunciation, this will be really easy because we haven't done much. It's just that once we have started at Iowa State, we have started creating these applied linguists who are partially computational linguists and partially, split brain applied linguists. They discovered that in the teaching of pronunciation there is a huge gap that can be very easily addressed. So almost all efforts in building software for teaching pronunciation focuses on automated recognition of students speaking and then different analysis and machine learning of how well they're speaking. There is another part to it. There is this perception part, and perception can be as confusing as production. It's actually very easy to build from the wealth of knowledge in applied linguistics that we've got. It's actually very easy to build some very effective activities for perceptive identification of phonemes. And there is no software right now that can generate frequency-controlled and personalized lists of minimal pairs for such exercises. And so I wasn't even aware about this gap because I was never aware about the state of the art in pronunciation teaching software. So this student of mine just came up with this idea because she had, both sides and both knowledge from both areas. And this has turned into a very interesting project. I haven't been allowed to release numbers yet because the student has not defended, and no published, which is more important, I think. But the results are very good. I'm very excited about your results as well. One of the very interesting things was that apparently the phonemes that everybody thought would be difficult for Russian learners of English are not as difficult as others. So she got some very interesting data from her students' performance on these automatically generated activities. So I see this whole thing as an exciting combination of different things feeding into other things, and this is all very circular and very, not like a vicious circle, but rather like a very productive circle. Just to conclude with something funny. At first, when I was told that perception of phonemes would be difficult, I said, how come? I mean, I've never had any difficulty with perceiving phonemes in foreign languages. It was not until that student, Dr. Kitty, I started to learn how to pronounce her name with appropriate tones. And then the activity she created for me was this. They all sounded the same to me, and only one Huishan was correct, and that was the way I should be pronouncing her name, because she took the time to learn how to say Evgeny Chukharev-Hudilainen. So I was paying her back by trying to learn how to say Huishan, and now I've learned it, but it just showed to me that perception is also very difficult, because at first all these combinations of tones sounded the same sounds, the same syllables, but different tones, and only one combination of tones is correct, obviously, but I didn't realize how difficult it would be. Thank you. Thank you for tolerating me. I didn't want to go to school.
Time for questions?
Whatever questions you have, yeah, with pleasure.
The RWT,
Yes?
is that freely available or is it restricted to Iowa?
It is restricted to Iowa State because of some issues with the original corpus of annotated articles. So yeah, it's restricted.
Do you see any point in the future where it might be made available?
RWT, I can talk to the PI on that project with pleasure and see if
And the same question about the abstract writer? The
Oh,
abstract.
CyWrite.
There are two things. There is the CyWrite that helps, that's a general purpose automated writing evaluation, which is publicly available currently. And this abstract, the idea is to make this abstract writing thing also publicly available. We are currently going through a very time-consuming process of clearing different things with our intellectual property office, who are very surprised. So they're probably even more surprised that they have to work with the English department than we are surprised that we have to go through this intellectual property stuff. They decided basically to commercialize it, but then they're learning that it's not going to work, so we're trying to make it freely available. It's not available right now. I'm working very hard on making it available.
And the Linguatorium?
It's publicly available. Unfortunately, it's not free because it's but it's cheap. It's very cheap. At Michigan State, students pay, I think, $16 per semester for access to it, and then they're adding additional modules, and it's all covered by the same cost.
But does it only work with English?
It only works with English as the target language, and it's a drawback. It's a very serious drawback, but it's also a benefit, because you can have a lot of these, flashcard. There is a lot of flashcard software that you can use, but because it's general purpose, it's not as effective. This Linguatorium system is built on a bunch of databases that describe the English language specifically.
Yeah.
So therefore, the activities it generates are very effective for the English language. Because, for example, you enter a bunch of words, and then it figures out what the semantic relationships between these words are automatically, and then it can generate more effective exercises this way. So yeah, unfortunately, only English at this point. I know that there have been some interest in Spanish and German, so these would be the next two languages. If you have any idea of another language that might be interesting, I would be very happy to pass this information on to them.
So which was the system where it was recording the student writing the system?
Oh, this is part of CyWrite. Sorry, I've confused you guys with all these different systems. This is the CyWrite system, and it's if you go to the CyWrite website. Here it is.
Why is Donald Trump on CyWrite?
Yeah.
Say again?
Why is Donald Trump on CyWrite?
That was the YouTube, that's just YouTube flashing more videos to watch.
Oh.
Why not to?
So under demos and downloads, you can see a demo of it. It's not the best. It's not the most current version. It's being improved constantly. But the plan is to really make it publicly available.
So as a student and I'm using it, those errors are flashing up.
Yeah. That was a particular experimental condition for that student. It's extremely confusing. So we wanted to replicate the behavior of things like Microsoft Word, highlighting errors as you type. So the next step is, of course, to prioritize these error messages so that they are not confusing. But then we decided not to just do a good job, but to do a great job. So we got this grant from the National Science Foundation. So in the next 2 years, we will be working on this prioritization of feedback with eye tracking, with keystroke logging, and with all other, kinds of biometric data that we can feed into the system. So this is all work in progress currently. But the idea is, of course, to make it available to other people, because that's why I like building things, because I like it when people use the things I build.
For the research writing, how were those 900 papers selected? Like, how do we know that those are actually the best examples of the writing, and then that they're not maybe perpetuating a style of writing that is culturally laden or somehow excluding certain people from being part of that success?
They just used disciplinary consultants. So in each discipline, they found a professor at Iowa State who seemed to be a good professor because they had gotten tenure and everything, and this professor has provided some feedback as to which articles this particular professor thought were good.
Okay.
In the abstract writing project, which is distinct from research writing tutor, she just looked at citation indices and she tried to come up with objective measures of a good paper. Yeah.
I just have, that was great, thank you so much.
Thank you very much.
2 questions. One is, so for the CyWrite, for the feedback that it gives, does it have a pool of feedback that has been already generated, then pulls and gives to the student, or is it automatically personalizing and generating feedback on the fly? That's one question. And then the second one is, how high does it go as far as, does it give higher level feedback as well? And I mean, where's the cut? Where are you at the moment? Because obviously the higher it goes, the harder it gets.
The more difficult it gets, right? And the high level feedback is, although it's more difficult, it's a lot of times more desirable. I had another student who graduated in spring, who did a module within CyWrite that really aimed very high. She looked at cause and effect discourse. So when students write consequential, I think, essays, this is called, there are a lot of different ways they can express causal relationships. They can say just because X, Y, or X therefore Y, but that's not very, sophisticated. So her system provides feedback about the sophistication, about the diversity and complexity of cause and effect language. And so it detects different patterns of cause and effect in student writing very reliably. And yeah, this particular kind of high-level feedback we can provide very reliably, turns out. There are other things which cannot be as reliable currently. So when we talk about high-level things, it's just that certain things seem to work, other things don't seem to work, and I guess we just work with what we've got. So cutoff will be very uneven, just because of the kinds of compromises between applied and computational linguistics we can find. With cause and effect feedback, it's also, it's also very difficult just computationally to find all the causal relationships. So it falls back to the user as well. So this seems to be a trick that we have learned, that we can actually ask the student. If the system doesn't know, ask the student. And this really comes from the applied linguistics side of things, which has been very helpful to me and very enlightening to me as well. As to your second question, how feedback is generated, currently, so there are templates, but they're very sophisticated templates, and there are a lot of them. So I would call it on the fly, because it's not just mechanically substituting things. There are some very interesting things in feedback generation. For example, if we give feedback to the student saying, let's say, you have a missing determiner here, you have a missing determiner here, the student does not introduce the missing determiner, then we could actually ask the student if the student knows what the determiner is, and a lot of times they will not. So there is a student model in CyWrite that describes which metalinguistic terms the student knows, and then the level of concreteness versus generality feedback is varied based on that. That's not in the production system yet, though, because it's still in the research phase.
Cool.
But yeah.
At Iowa, do you find that this is being used by your international students?
You have to say Iowa State, because I'll be offended if you keep saying Iowa. I just gotta say.
Right. No, I'm fine with that.
He's from Russia, he doesn't care. No.
Well, no. It's just because I understand how confusing it is. It it was worse when we had a conference and we had a participant who actually went to Iowa City instead of Ames, because that was worse. So just
Which one don't we like in the rankings? Iowa.
Iowa.
Okay. Is it international students or is it BA students, majors in English?
CyWrite? Currently international students, but the system is definitely usable for first year composition as well. There are components that are being used in first year composition. There are two reasons why we decided to stay away from anything beyond ESL for a start. One is because the expertise that we have is primarily in ESL. And two, there are some issues with the way the first year composition program is run and our ESL writing program is run. They run differently, and it's difficult to implement a system in both at the same time, just logistically. So I guess, yeah, that's two very trivial reasons: expertise and logistics.
Any other questions?
Thank you very
Well,
much.
thank you very much.
Thank you.